So hello, good morning, good afternoon, good evening, and welcome wherever you're joining us from. My name is Sarah Dukevich, and I'm a senior trainer here at Nimble Pros. And today I want to talk with you about some of the real-world CI/CD tricks that I've learned throughout the way that I've found has worked well with my clients for boosting their app's quality, and hopefully you'll be able to implement in your CI/CD pipelines. Today, we'll start with a quote from Martin Fowler, talking about CI/CD practices like automated testing and continuous deployment, how they lead to higher software quality, improved stability, and faster time to market. So today we're going to take a look at one thing for automated testing, plus a couple things to help with your CI/CD situation. We're going to look at formatters and linters, and so what the difference is and how you can format your code and enforce those coding standards. We're going to talk about code coverage through the code coverage metrics and how you can add them to your pull requests. So let's say that you have an open source project that you're maintaining on GitHub, for example, and you have contributors who are going to submit PRs. You want to make sure that their PRs meet a certain code coverage metric, for example. We'll be able to show you how you include that into your CI/CD. And then we'll also show how you can run integration tests using Docker containers in your CI/CD pipeline. Now, before we get into the details too much, a couple disclaimers to know. So our demos today are going to be screenshots from Azure DevOps and GitHub Actions that I took throughout the process of this. With Azure DevOps, they're going to be using the Ubuntu latest VM image for the sake of time. And the examples that we're showing in here are going to be for .NET 6 and higher. This is the reason why we were going to use the Ubuntu image for .NET. The reason why we're doing that is because we have the Windows time versus the Ubuntu time. So if you take a look at the Windows time you can see shows to be about 5 minutes and 8 seconds to go through this job. That's a long time to be waiting for a job to happen. And all we're doing in this job is we're going through and we're restoring, building, and formatting and testing. This is a very small project. So that took 5 minutes. But if you look at on the Ubuntu side of things, that took 55 seconds for the entire job. Now, I don't know about you, but I don't want to be sitting around waiting all day for my tests to run. I don't want to be sitting around all day waiting for my code to compile. I really don't want to be those XKCD fighters, the sword fighters. If you've ever seen an XKCD, it's a online comic. There's two folks who are fighting with swords, and their boss is like, "What are you doing?" They're like, "Compiling." I don't want to be that person. I'm sure you don't either. We're developers who want to be productive. So that's why we're using Ubuntu in this. Now, the first thing we're going to take a look at are formatters and linters. And what's nice about these is they allow you to enforce formatting and code standards throughout your code base. So let's say that you have an application and you may have like 5 or 6 developers working in a section of it. Well, those 5 or 6 developers may be writing code however they want to. So maybe you have somebody who prefers their curly brace right after the if statement, where somebody else prefers it on the next line. I know something like curly brace placement might seem kind of silly to some, but if there's consistent placement throughout the code, it makes it easier to navigate the code. It makes it easier to read through it and see those patterns. As developers, we're constantly working in patterns, so keeping a good pattern within our code makes sense. So formatters allow us to make sure that the white space is aligned properly, the curly braces are falling in a certain spot. Linters go a bit further. They allow us to apply other rules as well. So again, formatters, think of it like tabs versus spaces and your alignments. It's good to do these formatting things before you get them into the repo, but you can also use CI/CD to run some checks for you. And then linters will check to see, okay, variables, namespaces, certain patterns, certain other rules per se. So are you following a certain naming period or namespace naming convention? Are you putting numbers in the right format? And we'll see an example of that. But the main thing I want to point out here is if you're especially working on a newer project and you're letting new code into the repo, gate your code. And the reason I say that is that when you're early in on your project, you can set that code standard right then and there. Use formatters, use linters, and don't let the code go further than that until they pass those two. Because there's no point in running tests if the code isn't up to your standards. Get those standards and then run the tests. Because if you run tests on code that's poorly formatted, you're going to have to make those changes anyhow, which means you're going to have to rerun the test, which means you really want to have to sit through running tests multiple times. Not if you don't have to. Be smart about your CI/CD pipelines. Now, when it comes to linters, there are various linters out there. These are common ones that we've seen with working with JavaScript and CSS when I'm working in C# as well. So ESLint and JSHint, those are my JavaScript go-tos. CSSLint, StyleLint, SonarLint, CheckStyle are other ones. And then with the formatters, there's Prettier, which I've used with my JavaScript code, and then .NET Format, which I'm going to show you here today. So .NET Format I'm using with C# code. I've used it with .NET 6, I've used it with .NET 7. It works wonderfully for getting things done. What I want to show you is .NET Format --verify-no-changes. The reason why I'm using this switch is specifically because it will return a non-zero exit code if there are changes to be made. Why is this important? Because when you put it in your CI/CD pipeline, if you run this and it goes through your code and sees that changes need to be made, it'll stop right there. It'll fail on format, and then your tests won't run. And you have more time to get those formatted changes in before running your suite of tests. So now, as I mentioned at the beginning, we're talking about both GitHub Actions and Azure DevOps. So with GitHub Actions, this is what it looks like. So we have our setup.net. So that way we can execute the .NET command. And then we'll do the restore, we'll do the build, and then we'll do the format separately. Now you may be wondering, why do you have restore and build separately? So when you build your or create your GitHub Actions workflow for .NET the first time, this is what it comes as default. With the restore and build, format is not part of it, but format, that makes our code much easier to read. So with this particular example, the --verify-no-changes, it's not going to actually change the code. It can change the code locally. So I would say if you're running this on your machine locally, then run .NET Format and let it fix the files. But --verify-no-changes using your pipeline. And this is what it looks like. So this is running the GitHub action. Some things I want to point out is that you can see, for example, on like line 22, where they talk about inserting the white space. So it's already complaining about my white space being not good. And then again, I mentioned the exit code is non-zero, so it's going to come back as an error. That exit code is key when you're dealing with CI/CD pipelines and adding tasks or steps, depending on what pipeline you're using. That exit code is what will determine whether something passes or fails. Something to watch out for too is that if you have sometimes a verbosity, like a verbosity switch on your command, make sure that that doesn't interfere with the exit code. I have seen that with some tools where it does, and then you're like, well, my tool's failing, but yet it comes back with a positive exit code 0. What's going on? It's because it met the verbosity and not actually did the verify enough. So watch out for switches overriding like that. Now with Azure DevOps, that pipeline, what that would look like, it'd be .NET restore, the .NET build no restore, and then the .NET test, and the .NET format. That should have been format, not test. Let's take a look here so you can see. And we'll zoom in so you can see what I'm running. So you'll see command line. You can see that it's starting format. You can see, let's see if it's going to let me highlight it. Oh, of course not. Let's go back to Zoom and we'll get the laser pointer. So right here, you can see my .NET format, verify no changes. And when that fails, Now this particular screenshot is running Windows. This is the only screenshot for Windows I wanted to include so you could see that you can run this both for Windows and for Ubuntu. Notice the paths are D:, those are Windows paths. But then on our next slide, you're going to see when we run this in Azure DevOps pipeline, again, .NET format, verify, no changes. Those are paths for Ubuntu. So it doesn't matter if you have a Windows or Ubuntu pipeline, you can run .NET format -- verify -no -changes to make sure that your code is formatted nicely. Now, you also might be looking at this command and go, but Sarah, .NET format in this sense is running it for my entire application. I have a large application. You might have a solution with tens or so projects, 20s, 30s. How do you handle that? You don't want to format all of them. Well, yeah, I know that. I mean, formatting all the files takes time. And again, I don't want to be sitting around. I've got work to do. So the last thing I want is formatting all of my projects. How do I get around that? Well, this is where knowing the command line and how it works helps. So how do you run .NET format for only the change files? The key to this command right here. Git show --name -only --pretty equals an empty string. That empty string is crucial. Now you're wondering, but what's going on here? So let me zoom back out. I'm going to take this git show command, and then I'm going to pipe the output of it to the .NET format, verify no changes. This is -- include, space, and dash. This second dash after the sole dash after include. So there's a space and then there's that dash. That dash is going to grab the output from the previous and use it there. Now let's talk about git show name only -- pretty equals. So if you aren't familiar with git show and the name only, I wanted to show you what by default that shows you. So that's going to show you that last commit at your head. And in this case, it's got the hash, it's got the author, the date, the message, plus the files. The -- pretty equals will give you just the files. If you read up the help file or the man page for git show, you'll notice there's other options you can put in pretty equals to get other pieces of the commit. But for all we need, we just need the files that changed. So git show -- name -only -- pretty equals empty string gets you your list of files. You'll pipe that list of files to .NET format with the -- include space that dash. And this works really well. So you can see here in Azure DevOps formatting only the change files. If I look right here, you can see there's the command that I was talking about. And you can see that it changed or looked at 2 of those files, and it's formatting only the changed files. GitHub Actions will take that same approach. So taking the git show and then piping it over to that .NET format. Again, that -- pretty equals empty string is what is crucial to this command, because that's what gets you just the list of files that changed. Okay. Now that's formatting. Let's look at linting. So formatting is, again, it's your code style. It's the CSS of code essentially. So it's the how pretty is your code? How does it read, spacing, lineup, and so on. Linting takes it one step further. Linting will apply different rules. And what I want to show you is super linter. And the reason why I want to show you super linter is because it has linters for a collection of languages. And I don't know about you all, but I haven't worked in a one language solution in a long time. I think my entire career, it's been multi languages in my solutions. We've got C#, we've got CSS, we've got JavaScript, HTML, YAML, Terraform for some things. So these are just some of the many languages or tools that I have to use in my day-to-day, and I'm sure you have some as well. SuperLinter has various linters for those different tools. What's nice is if you're working with a very small, like maybe you're working with HTML, CSS, and JavaScript, and that's it, there's a slimmed down version of SuperLinter as well. SuperLinter will run the various linting tools based on the environment variables that you feed it. And in this example, I do mention it can run a Docker container as well, and we'll show that when we get to Azure DevOps. I'm going to zoom in so you can see that these are the different kinds of things that a linter will look for. So notice it's complaining about things like the hex code, for example. It could be simplified down instead of the repeating characters to something a little more simpler. You can see that the value notation for your alpha, for coloring, for RGB could be 5% instead of 0.05. So things like that. Linters get a little more specific in that kind of situation. With the superlinter environment variables, so this is what determines which linters to use. The first question I had going into it was, hold on a minute, I don't want to lint my whole code base. Can I only lint just the files that changed? They make it easy. There's a variable called validate all code base that you set it to false, and that'll only validate the files that change. Now there's a gotcha to that. If you're running Azure DevOps or running SuperLinter in a Docker container for another platform, for example, that validate all code base gets set to true if you do what's called run local. And we'll talk about run local here when we get into the code. You can specify your own rule files. You can inject your own SSH keys if you have private dependencies that rely on them. You can also inject your own SSL certificate. And there's all that guidance is on the SuperLinter site. All right, so let's look at SuperLinter and how do we add this to our GitHub Actions and how do we add this to Azure DevOps? So with GitHub Actions, there is an action already for it. If you've seen maybe older blog posts, you might see an action known as GitHub/super-linter, but recently they've renamed it to super-linter/super-linter. So this is the GitHub action. We'll go ahead and zoom into where we're looking at it. So superlinter v5 is the current version as of this webinar. There's the validate all code base is false, which means it's only going to validate the files that changed. But then we get into specific validators. So we're going to say we want to validate our CSS. We want to make sure that it looks clean. We want to validate C#. We want to validate our JavaScript as well. All the other languages, because I don't call them out explicitly, they are set to false. So once you bring in one of the validators and explicitly call it true, the rest are assumed false unless you include them here. And then the default branch, so what branch should it be looking at? Nowadays I use main, so that's why that's there. And if for some reason it needs access, you'll want to put a GitHub token in there with the secrets GitHub token. So that's GitHub Actions. Now, something to note with SuperLinter is it does come from GitHub, so it was designed with GitHub Actions first. Now, disregard the field to call. There was some status issues when we were looking at this. However, notice the errors. So notice that we have 2 errors in C#. We have 18 errors in CSS. And then we have 3 errors in JavaScript. So the linter can find that and it puts it all in a summary at the end. For Azure DevOps, you need to run SuperLinter in a container, so in a Docker container. And then there's a flag on it called run_local. This will bypass the GitHub checks because superlinter was written by GitHub for GitHub Actions initially, there are some GitHub checks that runs. So this run local applies, again, running in a Docker container. Something to note, this is the gotcha that I ran into when I first was working with it, is that validate all code base is set to true, which means it is going to validate your entire code base, unless you can tell it to go to a folder. Then you can pass in a -v with the path of the things that changed. So with superlinter in Azure DevOps, what does that look like? Well, we have a couple scripts that we add to our YAML file for our Azure pipeline. And so what does that look like? Well, the first step that we're going to add is we're going to pull the superlinter image. And if you're wondering why we don't have to do that in the GitHub action, again, the GitHub action has that already encapsulated for us. It handles that. But then when we get into here, this Docker run statement, notice we have the -es for those variables. And then -v is for the path that we want to lint. So we're going to run local equals true because we're running in the Docker container and need to bypass the GitHub checks. Then we're going to tell it validate all code base equals false. Unfortunately, run local will override that. Validate CSS equals true, C# equals true, and JavaScript ES equals true, because I want those all to be validated by the linter. And then for -v, just lint these files. What does this look like on the output of Azure DevOps? Notice that here's the summaries. So 2 C#, 3 in JavaScript, 18 in CSS. Now, when we look at the CSS, I'm going to zoom into the CSS so you can see, like, there's some of the checks that are going to do it. Property no vendor prefix. It's going to look for various media rules, features, notation. But if we were to look at where these happen, these actually are happening in Bootstrap files. Bootstrap? Do I really want the linters to Bootstrap or to go through the Bootstrap stuff? Those aren't my code. I don't really want to see that. There's got to be a way. How do I exclude those files? Well, superlinter does have another environment variable that we can pass to it. So those -es in Azure DevOps. So -e filter _ reject _ exclude, and then you can tell it which ones to exclude. So you can say ignore all of those that are under the www root lib folders, exclude all of those. I don't care about any of my third-party libraries. Don't lint their stuff. In GitHub Actions, you just add another variable in this env section, the same name, filter, regex, exclude, and that same pattern. So the names and the patterns, or names and the values, stay the same. So if we go back and forth between them, it's just that with Azure DevOps, because we have to run it in a container, we have to pass the variables in using -e or Docker environment variables. The other thing you'll notice on these screenshots is I also added validate YAML because we have some YAML in this particular project. So you can add validators as you need. All right. So formatters, linters, they'll help to make your code a lot cleaner. Cleaner code tends to lead to better code quality and better app quality as well. Now let's talk about running tests against a real database using Docker containers. So if you think about your integration tests or your functional tests, as some places may call them, you may find yourself going, I'll just use an in-memory database for that. But really, is that what you want to do? Or do you want to be able to test using an actual database? Well, you can use it using Docker containers. And since we're already talking about Docker for Superlint and Azure DevOps, now we're going to take a look at Docker for another case. So we're going to use the example of SQL Server. Microsoft SQL Server because, again, we're talking .NET. SQL Server is a common database that we've used. But don't let this be limited to just SQL Server. This should also get your brain thinking about other real databases that you could be using. So maybe MySQL or Postgres. There are Docker images for those as well. So let this be that little seed to add for your ability to just add real databases to your integration tests. For SQL Server 2017 and higher are available in Ubuntu-based Docker images through the Microsoft Artifact Registry. So you'll be able to run these on Ubuntu. We're not talking about slower Windows-based images, which is good. For these tests, we'll have two containers. We'll have what's known as a database container and the tests container. All right, so the tests container is where we're going to run our tests from, and that's going to have a Docker file. This is what we're going to do is we're going to copy the code to the Docker container. We'll run .NET test with code coverage, and we're going to use something called Docker Compose Wait to help us wait for other Docker images. So what's going on is with the two, so let's go back. With the two containers, you have a database container, it's your standard Microsoft SQL Server image. It's going to come up, but if you don't time it right and try to run your tests without this wait, what could happen is your tests could try to run against a database container and that database container is not up yet. And so the test will fail because it can't connect to the database. Well, rather than setting yourself up for failure, the Docker Compose wait, what it'll allow you to do is it'll allow you to say what you want to wait for. And so in our Docker file, in our Docker Compose file, we'll have two different containers, test and database. And for the test, we'll tell it to wait for database on port 1433. Port 1433 is the standard SQL Server port. So we're going to use this Docker Compose wait so that we run our tests once the database container is responding. So once it's listening, once we can see 1433. And you can see here in the screenshot, you zoom in so you can see that it's going to check and see it's not yet, not yet, not yet. So it's not going to run the tests until it can see that. Now, is there a timeout? Yep, there's a timeout. As you can see here, you can set the timeout. In this case, it defaults 30 seconds. It'll retry every 5 seconds. So there are configuration settings for wait that you can use. But this is a handy plugin to use for working with Docker containers, especially multiple Docker containers, when they depend on one being up. Now, our test container, the Docker file, there's a lot going on in this bottom section, but let's get through. So what we have here is the .NET 7 application. So we need to bring in the .NET 7 SDK for our base image. We're going to set our working directory to app. We're going to copy our code. So this is where our tests are. And we're going to copy that to the Docker container. We're going to grab Docker Compose wait. And the latest version for this webinar is 2.12.0. Again, this is running the ability to work with the wait command. So once we add it, we want to make sure that we make it executable. So that's the chmod +x. Make sure we can execute that wait command. Then we have this large command here. And the reason why it's large is because file paths, those happen. So we're going to run the wait command. We're going to also run .NET test. In this case, we have the .NET 6 specification in here that we're working with. So .NET 6 tests for specification. And we're going to take a look in this particular one. So this is the Ardalis specification repository. And so he's got unit tests, he's got integration tests, and then he's also running through those and getting their code coverage. Hence why you see things like target dir and cobertura, the report types, things like that. So this is going to run the test with the code coverage for both the integration tests and the unit tests. Again, this is all within the tests container. Now our Docker Compose, what does that look like? So as I mentioned, there's going to be two containers in the Docker Compose. There's going to be one called tests and one called database. And I bolded those specifically so that they would stand out for looking at this. We will have the environment. There's this variable here called wait_hosts. This is what that wait command is using and waiting for. So it's going to wait to see this database on port 1433. Once it's responding, then it'll stop the waiting. But until then, it will wait. This particular example also shows we're using SQL Server 2022 latest. You will see in some other demos, if you do some searches online for other people who are using this, where this will show something like just SA_password. Nowadays, it's MSSQL_SA_password. And yes, that is a very super secret password. Don't tell anybody that's what I'm using. Now, when it comes to using the Docker files, so we have the Docker file for the tests container, then we have the Docker Compose to build our two containers, then we need to build it, and then we need to get it running up. So that's our what we call runtests.sh. So it's a shell script. Now, why are we doing Docker Compose and shell? Because it makes sense for what we do, but you could also do this in things like a PowerShell script or other scripting tools that your clients prefer. We just happen to use shell scripts in this case. Now with shell scripts, just because they are a .sh does not mean that they can be executed as is. You still have to set them executable. And that applies for both GitHub Actions and for Azure DevOps. So in GitHub Actions, you can run that with your chmod 555 run tests using the run and name. And then Azure DevOps, this is going to look really similar. The difference is instead of run, it's script, and instead of name, it's display name. Now, when you run those tests and you set the shell script to executable, the next thing it's going to do is it's going to be able to run that runtest.sh. If you leave out the chmod 555 step, you'll know something goes wrong when it tries to run the test.sh and says it cannot find the executable. I've run into that in the past as well. So don't forget, just because you have a shell script isn't enough. You have to make sure you can execute it. Now, what does this look like? Well, this is our Dallas specification demo. And so you can see here that there's integration tests that get run. And then, as I mentioned in the code, he runs the integration test with code coverage. Well, those code coverage metrics get carried on into the output as well. So I wanted to get a screenshot of that so you could see, well, what does that look like? Questions so far? Well, all good. Okay. Moving along then. So we've seen how to run formatters and linters in your pipeline. We've looked at Docker and how do we set up containers to run your integration tests. And again, this demo shows .NET, but let that just be a seed. If the database platform of your choice has a Docker container image, it will follow the same pattern. So it would still follow the test container and the database container. It would just be your database container would be whatever your database choice platform is of choice. So like I said, it could be something like MySQL or Postgres, which I've done as well. For that, it comes down to then the Docker Compose, making sure you're using the right image, and then any additional environment things that are required for your database. But then everything else, run tests, it's going to be the same. All right, speaking of code coverage, so let's talk about code coverage. Code coverage is one of those features in Visual Studio that I always was just like, well, it's good to know that it's a feature, but unfortunately it's at the enterprise level. Prior to here, I was working for myself, but as a person of one, I can't afford an enterprise license. That would be ridiculous for me to do. However, code coverage is not just for the enterprises. We too can get it as common developers, and this is how we do it. So code coverage for all? Yeah. Oh yeah. There are two cross-platform tools out there. One is called Coverlet and the other is called Report Generator. So we're going to take a look at Report Generator and the reports it generates. And then we're going to talk about another tool that can use our Coverlet reports and convert it to a smaller markdown chunk. And then how do we put that as a comment on the PR? This is a thing that we use in a lot of Ardalis's open source packages. So you'll see it for guard clauses. I think it's in specification, probably in result as well. But it allows us, because we have these open source packages, these open source projects, if we're having other people contribute to our projects, we want to make sure that we can show the code coverage on their PRs. So these are the steps we took to get there. So first, I want to show you Report Generator, because Report Generator is pretty neat for creating the reports from our Coverlet results. This will give you some ideas on how you can generate reports that might be useful for people in your organization. But these reports that I'm going to show you are not the reports we're going to commit to a PR, and you'll see why. Their size is a little more than what we want to show on a PR. So first, let's talk about adding to GitHub Actions. There's a lot going on here, so let's zoom on in. So first, we're going to run our code coverages. And when we do that, we're going to collect. So I guess let's go back a step before that, which I don't have the slide for. And that's installing Coverlet. Let me go back here. So you have to install Coverlet in your tests in order to be able to get those metrics. And it is a new Git package. And I know I have a slide later on that will show it, but it is called coverlet.collector. Then when you run your .NET test, you're going to have this -- collect explat code coverage. This will grab your code coverage metrics and statistics for whatever tests have this on it. Now I say whatever test because typically if you're running code coverage, you might be checking the code coverage of your unit tests. You might not be necessarily looking at functional or end-to-end or integration. It might just be on unit. Whichever tests you want to do the code coverage on, make sure that it has this Coverlet collector NuGet package. Now this other thing, so that's the name here, code coverage and test. You're just going to run .NET test and get the statistics. But report generator, this report generator GitHub action, what it'll do is it'll take your Covertura files, so that what gets generated here by your .NET test. The XML that is generated is a standard Covertura file, so it's going to take that XML and it's going to convert it to, and the example I'm going to show here is an HTML summary. It has a lot more options than HTML summary though. The reason why I show HTML summary is just so I can show you the extensiveness of it. The markdown summary still gets to be in too much detail. So there's that. Once we have a report generator, then I have it uploading the artifact. And that's just so that I could show it for this demo. If you would want to put it into some other place using another GitHub action, for example, to put it into like a Jira or something, you could do that as well. So this is the output that you see from report generator. And I'm going to zoom in so I can call some points out. So first, this is just a standard report. And again, report generator is a free cross-platform open source tool. You can use it as is. However, I am going to point out this gotcha here is that they do have a pro version for sponsors with more details. So if you find that you need more comments or methods, more details on how it got its thing, more metrics, upgrade to the pro. Otherwise, this everything else I'm showing you, this is all free open source. And like I said, cross-platform as well. So it's going to look at the cobertura and it's going to tell, in our case, there's only 2 assemblies. So it's a smaller one to look at. You can see when this was run. And then it can run any risks. Now this particular screenshot, I have it so that it's grouping by namespace, but I have it so that it is looking in detail to the most detail possible. So you can see what does that look like with the drill downs? What does that look like with the metrics? And you can see here, we get into like line coverage, we can get into branch coverage. You can see the calculations versus numbers versus percentages. We've got the progress bars. All of this gets generated by the report generator. So this is the most in-depth. But if we wanted to go back up to a higher level, that's what we have here. So again, looking here, grouping, I'm not grouping at that point. So you can see it at a higher level, what all are we looking at? Everything is broken down. And the code that I'm evaluating here, this is the clean architecture template. So I did a webinar last month about the clean architecture template and getting started with it. So I expect these numbers to be fairly low. It's just a template. It's not actual application. So you could run this as part of your CI/CD using the steps we outlined. So again, that's this part here. Now I'm only showing it in GitHub Actions because, again, we're kind of watching our time. But if you want to learn more on how to do this also in Azure DevOps, feel free to reach out to me afterwards. All right, now code coverage and GitHub PR. So again, let's say you're running an open source project and you have people committing pull requests to your repo. You want to make sure code coverage is met. So the first thing you're going to want to pay attention to is in your GitHub workflow, make sure you have a trigger for pull requests that are going into main. So pull requests with branches main. This is the kind of summary we want to generate. So notice it is very condensed. There's a line rate %, a branch rate %, a complexity number, and a health. We're not getting into the details that report generator was showing. So we're not going to use report generator in this case to generate the markdown. We're going to use a different plugin for that. Now we're doing this in 2 workflows. And the reason why we're doing this in 2 workflows is because we're going to have one that will get the coverage statistics and it'll convert it into markdown. Then we'll have another that will have the permissions to write to the pull request. So managing the permissions, I like to make sure that those permissions are only going to be where they need to be. And so if I only need write for a certain part of it, I don't want to give write access to the entire pipeline. I'm only going to give it to where I need it. What's nice is that there's this workflow run event in GitHub that will allow us to go, okay, run this workflow. And then once that workflow is done, run this other workflow. So workflow run is used for that. And workflow run has the ability to do reading and writing. Now, the 2 workflows, again, build is going to run the tests, get those coverage statistics. It'll take that cobertura file and convert output into the markdown. And then it's also going to save the PR number to be used for the other workflow. That way that second workflow will grab that PR number in the markdown. And then it's going to use that workflow run permissions to then write that markdown as a comment on the PR. And the plugin that we use is what's known as a sticky pull request comment. So that means that there's just one comment. That means if somebody submits more code to that pull request, only that comment gets refreshed. It's not like you're going to have multiple code coverage comments. We keep it down to one. So that sticky comment was probably one of our favorite plugins to find. So you're going to add the coverlet collector to your test project. When you want to gather your coverlet, the metrics, you have to include the -- collect explat code coverage as part of .NET test. Then we're going to copy that coverage Covertura file to a proper location. This step is actually optional. We don't need that anymore. But we do want to convert the Covertura into a markdown, then take that markdown and add it to our PR. Again, yes, you could do this with report generator, but it gets to be a little more detailed than we want it. Now, in Coverlet collector, as I mentioned, is a NuGet package. So in our unit test, we made sure to add a Coverlet collector that way. Then we run .NET test with the -- collect explat code coverage so that it gets our statistics. You can also tell the results directory to know where it's going, and you can get very specific in your TRX files and file names. Then we're going to convert it to Markdown. Now, when we convert it to Markdown, we're using action called IronGut Code Coverage Summary. And this is what's going to take that XML file, the Covertura XML file, and turn it into Markdown. It'll also create a badge, which is part of the output, which we'll see that here in a couple slides, or I can also go back here in a minute. We're storing the code coverage Markdown in an artifact since we're creating it in one workflow, but we're going to use it in another workflow. And we're going to create this as long as there's a success or a failure, you can see that it's going to create it with the retention of 1 day. We also have saving our PR number, and that's just so that we have a spot for that. And then our PR number will also have a retention of 1 day. We don't really need it longer than the lifetime of the pipeline itself, just that run. So that's why we're going to do a quick retention day. So what does that comment look like? Again, we've got the badge right here. And then this is what's happening with the conversion from the Covertura XML using IronGut's plugin or IronGut's GitHub action. So much more condensed than what we need. You'll notice it gets commented as GitHub Actions bot. So that's how that appears in the PR. So the second workflow is what actually puts the comment on the PR and is triggered again through the workflow run event. And we use Marikino's sticky pull request action for adding that markdown to the PR. Again, workflow run has that read write token that we needed. And so that's why we use workflow run with our PR number steps. So we're using the WID's action download artifact. This allows us to download the artifact from another workflow. So we have the first workflow, then the second one. So you can see here, you tell it which workflow it's coming from. You're going to get the PR number. We're going to read that in because that way we know which PR we're putting this comment on. And I do have a comment on there about debugging just to make sure as we were going through that it was picking up the PR number correctly. Next, you want to take it and get the markdown. So we're downloading the markdown using the same DWID 6 action download artifact action. And finally, we want to append that markdown to the PR. So this is what it looks like for the last step, which is Marikino's sticky pull request comment. And we take the number, and yes, we want to recreate it. So what happens is when this runs again, we're going to take out the comment to recreate it. It's a sticky comment. And then what file or which markdown file do we want to use to append to the PR? This is the markdown file. So today we looked at formatters and linters and adding those to our pipelines, both for Azure DevOps and for GitHub Actions and the GitHub Workflows. We also looked at adding integration testing using Docker containers. So we're doing integration testing on live databases instead of an in-memory database. Thank you, Docker Containers, for making that happen. Our demo included SQL Server, but again, that should just plant a seed. You could do it with any of your databases that have a Docker container image. And like I said, the ones I know for sure, MySQL and Postgres do have it. And then finally, we started talking about code coverage and the reports. So we looked at using Coverlet to gather the statistics for us. And then we used Report Generator to generate the fancier, more detailed reports. But then we also used Iron Guts reports to take the Copertura XML, convert it into Markdown, and use Marikino to write the sticky pull request comment. So these are some of the many real-world tips and tricks that I have for CI and CD, and how you can make your code base better and how you can get better quality in your apps. But if you have any other questions, I will gladly answer. I have all sorts of other tips and tricks that I will be blogging about here soon. All right. So we have a couple questions. So when it comes to GitHub Actions, the best way of testing and debugging actions. So are you talking about creating actions yourself or using somebody else's and debugging? Okay, creating actions yourself, that I don't know. I haven't created actions from scratch, so I'm not sure, but I can take a look and see what is out there for that. I would say when I'm working with other people's GitHub Actions, that's where you see something like this here, for example, where I'm going to do a lot of echoing if I'm working with environment variables, or I might have some console.write lines in my own code to kind of give me some kind of guidance in the logs. So kind of like just log debugging. For GitHub Actions themselves, I would say, yeah, there is an action called ACT that might work for it. Again, I myself have not created a GitHub action from scratch or haven't really created my own, so I wouldn't be the best qualified to answer it, but I can look into it and message you about that, Saladin. All right. And then the other question we have here is, what is the best option when we need to create database schema and see the tables with test data and integration tests? So for that, I want to bring over the Ardalis specification. Let me stop the share there because that's only sharing the slides. I'll show you what that looks like. So the Ardalis repos are the ones that we use for examples a lot because he's got different ways to approach these. All right, let me open it up in a spot where it makes sense for you to see this. So we're looking at his specifications. I'm going to go ahead and share the screen and share screen 1. Okay, so you should see my Visual Studio. And with the Visual Studio, I am working with Ardalis specification. So if you go to github.com/Ardalis/specification, that'll get you to this project here, which is Ardalis.specification. And the way he takes the approach here, so I'm gonna close some of these. We're looking specifically at specification entity framework core. I'm gonna go ahead and open that. So he's got the entity framework core. He's got a bunch of extensions and things in here. But what he's got is under this test fixture. If we go under shared database fixture, this is where he sets the connection strings for Docker and for local database. And so it'll go through, he uses a project called Martin Costello to help with the SQL local database stuff. Otherwise, it's entity framework. So entity framework will handle the schema as it does. Now for seeding the data, I mean, that's going to vary based on your project and how you would do it. But in this case, I know for a fact that he has got that seed data in, where did I see that? In unit tests. Not unit tests. Where did he put those? He has those in entities and he calls them seeds. So I'm going to do a search for seeds. There we go. Oops. So he's got his seeds built this way. So for example, he's got the customer seed, which is a sample app core, sample app infrastructure. And then also so the customer seed is for the app itself and how you would seed the database. So you can see, where does this get called? This is getting called here. There's this seed async task. That seed async task, you can see, is getting called in program.cs. So typical pattern is you might check to see if there's data there. If the data is not there, then call the seed. And then for the tests, the seeds look like this. So we have some constants, but then you can see it's typically a list of whatever the entity is. So a list of addresses, a list of companies. There's bringing in some more like store. It has a lot more going on. So you can see how he builds it and deals with the seeds that way. Now, in this particular one, he uses unit tests. I've also seen in, I want to say maybe it was the clean architecture. One of them has a shared test utilities. And so you would see the unit test project, you would see the integration test project, you would see maybe a functional test project, but then there'd be a test utilities. And in that test utilities that gets shared by all the tests, that's typically where I would put the seed. Because that way you can use the seeds for the functional test if you need them. You can use the seeds for your integration, and you can use them for unit and not get them bound up together. And not rely on the app either. All right. Couple more slides. So additional resources. So let's say you're at a company who is having a hard time coming around to CI/CD. There's this book, Accelerate, that I learned from the crew at DevBetter. So DevBetter is one of our communities that our Dallas has for mentoring other developers as well. And one of the things that they have is a book list, and Accelerate was on their book list, but it has a lot of survey results. So it's very much a scientific, this is the research that we did, this is how we did the research, and these are the results. But it has a good story behind how to adopt CI/CD in your organizations. So if you're watching this webinar and you're like, how do I get my company to adopt it? And I happen to have somebody who likes to read a lot, Accelerate is a good book for that. Now in today's demos, I show .NET Format and Superlinter, as well as sticky pull request, comment, and Coverlet. So we have links for all of these. Then we have some blog posts that will be helpful for you for implementing these as well. Rest assured, don't worry if you're like, I don't have these links. After this webinar, if you've signed up for the webinar itself or signed up for the recording because you knew you couldn't make it, we will be sending out a list with all of these different links in it, as well as a link to the recording. So you'll be able to see that afterwards. But we have blog posts. You can see some from myself, some I've written for work. The running integration tests in the build pipelines, that's from our Dallas as well. The slides will be in as part of the recording, what it can capture from there. And then also we do have some upcoming webinars and other events happening. So I will be leading 2 more webinars. I will be leading the Intro to Domain-Driven Development with C#. And that's going to be July 26, 2023. And then I'll be doing a DDD conversations using domain storytelling on August 24th. Then in September, I get to pair with our Dallas, and we will be delivering an event storming workshop. More details will be available. If you have already signed up for the webinar or for the recording, then you will be able to get those links in your email. and we will send notices to give you a heads up of when those registrations open, as well as what those will cover. So that's coming up. Mark your calendars. We're excited about this. And then if you're interested in learning more about how to implement these CI/CD tricks in your own pipelines, or if you need help maybe upgrading to .NET 7, or if you want training for your dev team, for example, in clean architecture, DDD, or any of the other software architecture topics out there, contact us. Reach out to us on the Nimble Pros contact page. We'll gladly talk with you to see if there's an opportunity there that we can help you with. All right. Excellent. Well, thank you for coming. I hope you enjoy, and I look forward to sharing this recording with you when it becomes available. Thank you. Have a great day.